Hi guys, now we are going to design a footing called the mat footing. For a mat foundation design, firstly we need to have the values or the resultant values from our previously designed building from our any software like ETAP, SAP, StatPro, or anything. We need to have the axial forces of the columns at the base level or the uh, shear forces of the columns at the base level. We need to have all these base reaction values so that we can assign those load values to the mat footing values. So firstly, before designing a mat footing, as we will assume our own data and do the design. So let us assume a mat footing of 18 by 18 meters of dimensions, and we will be having 4 by 4. That means 16 columns in the mat footing. And let us give our assumed column dimensions. For that, first we need to go for file in a new model. Instead of opening, if you have the another previously designed model, which all the values are described or already given, you can go for the new model from the existing file, or else simply go for new model. That select the design code as Indian Standard IS 456 and set the units as metric. Here we can change the unit system, go for the metric default, and design preferences. In design preferences, go for minimum cover slab and change the clear cover to 50, as we will be having our cover as 50 and top cover, bottom cover, and our rebar as take 22 for matte foundation, and in the slab as layer B as it is, and then click OK. And now go for grid only, as we don't have a matte foundation prescribed format, as we have only base mat, but we just let's go for a grid only system so that we can have our own dimensions and our own columns. And for 18 to 18 meters of a footing mat foundation, we need at least of 19 grid lines, as if we take each 1 meter as one interval spacing of the grid line. So take x direction 1 meter spacing and y direction 1 meter spacing and click OK. Now we have the grid lines of our mat foundation. Now we need to define our materials. Go for define materials and add new material. Add new material. Go for M40, and these are all the values which we need to enter. Go for concrete. These are all the values which we need to enter. We need to enter the unit weight, modulus of elasticity, Poisson's ratio, coefficient of thermal expansion, shear modulus, and the concrete cube compressive strength. All these values. We can get all these values through the Google or through any other browsing history you can take, or any other research papers also. So for 40 M40 grade of concrete, we will be having a unit weight of 25 and modulus of elasticity of 5000 root 40. That may be around 32,000 something. Let us assume everything. And then Poisson's ratio is 0.2 and the coefficient of thermal expansion is 0.00000055. And the cube strength is M40 40, and then click OK. And again add the new material of HYSD. Enter the unit weight per unit volume as 77, and Young's modulus of elasticity as 2 into 10 to the power of 5, and minimum yield value as 415 and maximum yield value as 485, and then click OK, and then click OK, and then go for define slab properties, add new property, name it as a footing, and go for mat 40, that is M40, and give a thickness of 200 degrees and click OK. And again define column properties, add new property, column 1, mat 40. Let us have a column, 3 different types of column properties, and column 1 mat 40, and give the column dimensions as 500 by 501, and then click OK. Click OK, and again add new property, column 2, and it is of mat 40. Give this dimensions as 600 by 600, and then click OK. And again add new property, give it as a mat 40, and the dimensions as 650 by 600. Let us assume anything, and then click OK, and then click OK. And now define the soil subgrade properties. Let us assume it is about 30,000 of soil subgrade properties, and modify the soil subgrade property. And here we have 20,000. So make it as a 30,000 by changing here to as a 3, and then click OK. Click OK, and then again define column properties completed and the soil subgrade properties also completed. And let us define the load combinations. We see the load patterns that dead load and live load are mentioned here, and define load combinations, a new combination, load combination 1, dead load 1, and live load. Dead load as 1.5 and live load as 1.5. Take it as a strength, ultimate strength, and then click OK. Sorry, here we need to change live load, and then click OK. And again add the new combo 2, load live dead load as 1, live load as 1, and check all the service loads condition. That means the normal, initial, and the long term. And then click OK. Two load combinations are being selected, and then click OK. And now for defining, nothing is left. And now for we need to draw the footings and columns. So for draw footings and columns, so go for draw slab area, and make sure that the property is selected as footing. Now click on the grid area. Point number 1, point number 2, point number 3, point number 4, and I can return to the point, first point. Footing got drawn. And now draw the column. Column 1, below is of none. So make sure that below is none. Above is column 1. Height below is 0. Above is, let us assume 2 meters of plinth beam level. Then go for 2, and then draw the column. Column 1. Make sure that let us assume that 2 meters distance from each and every center there are columns 1. Column 1 is completed. Now draw column 2. Column 2, let us draw at a spacing of 4 meters. And go for column 3. Make sure the column 1 we select here. As this is all the assumed data, let us have our own values and our own model. And then click escape. Click, and now this is completed. And now we need to select, or else go for the select contributor. And now we need to draw the strip line, means strip lines. So for that draw design strips, and our least dimension is of 18 meters, and we need to have at least of a 0.25 times of the least dimension, and the 0.25 times of 18 is 1/4 of 18, 4.5. So start with the as the 4.5, and again the 4.5, 4.5, and 4.5. And now strip layer A and column strip. Now draw strip layer A. And now change the strip layer as strip layer B. And all the strip layers are being drawn. To see the strip layers, let's just go for a point of view and then go for set display options, the labels, show width and show signature, and okay. These are all the strips layers we have drawn. And then now click OK. And now we need to assign the rebar material as HYSD 415 to all the footing columns and rebars. To do the thing, right click on the footing, make sure that on the left bottom we will be having our footing selection. So that go for design rebar, change here to HYSD 450 and then click OK. Click OK. And then go for the column design. Nothing is selected. One point is selected. The column rebar material is HYSD already preset. You can check every column, it will be HYSD 415. Now we need to assign for the design strip. Do the same thing as we are doing. Completed. Now we need to give the load. Select all our points of same dimension. Make sure that here 8 points are selected on left to bottom. Then go for assign load data, point load, dead load, and give it has 600 kilonewtons, and our dimension is of 500 by 500. So place the existing loads and then click OK. And again select get previous selection and again assign load data, point load, go for the live load and here give double of it 1200 and then save and click OK. And again now select the remaining thing. Now all the loads have been assigned. Now just run the analysis. Run analysis. Give the name of as we can see that here the design is got some fault. So that since we have not assigned the soil properties, support conditions. So right click on the footing, left click on the footing, one area and four edges are selected and go for assign support data, soil properties, and as we have already given the soil one properties and then click OK. Soil properties are also given. Then run analysis. Now we can see the analysis values. So now we can go for run and analysis and design and go for this display, show punching share values. Here we have all the punching share values are of less than 1. Hence, our putting mat foundation is okay. If we have any values of here is different, then we need to go for define and change the slab properties of footing. Modify. As we are in unlock position, we need to unlock it first. Define slab properties, footing, modify our slab footing, and change here the values as 200 to 500, and then click OK. Click OK, and then you can go for an analysis again. As we have already got these values as safe values, so no need to do this thing. As our values all are the same values. And now if we want to go for the detailing view, go to run detailing, click OK. And we have the detailing. Now if we need to see the detailing, go for drawing components, slab views. This is our plan view of the our footing. Bottom rebar plan view. And for if we go for drawing sheets, and if you want to build up the quantities. So this is how the foundation design will be done.